All right, guys, so this is the video that goes with section 1.3, and as you can see, we're going to be modeling with linear functions. Hopefully this is review for most of you, as most of you seem to be pretty good with linear functions, so you've definitely done this before, but let's just hope you remember some of it, or if not, hopefully this is just a refresher and not a relearn. All right, so if we look at this exploration, it says a company purchases a copier for $12,000. So that's our initial price. The spreadsheet shows how the copier depreciates over an 8-year period. Okay, so when we buy it after 0 years, it's $12,000. That's what we bought it new. After the first year, right, it goes down to $10,750. So it loses $1,250. Okay, and then to the next year, from 1 to 2, it loses $1,250. This is what depreciation means. Okay, so every year you have a piece of equipment, even if you don't use it, it goes down in value. Okay, so all of these here, so on and so forth, they go down $1,250 a year. All right, so we want to find a linear function, the equation of a linear function that represents this. All right, so we could say the value with respect to time, so we're going to do v of t equals, okay, well, we start at $1,200 or $12,000. So it's going to be something plus $12,000. Okay, and we are going to depreciate, so we're going to go down $1,250 per year, so I'm going to put t. Okay, so our function would be negative $1,250t plus $12,000. Okay, so if t equals 0, we get 12,000. If t equals 1, we get 750. If t equals 2, we get 950, and so on and so forth. All right, so it says interpret the slope of the graph in the context of the problem. So the first thing we have to do is what is the slope? Okay. This right here is the slope. The slope is negative 1,250. Okay, and this represents the amount of depreciation per year. All right, so let's kind of review a few different ways we have to write the line of equation, or the equation of a line, okay? Now, just to recall, we eventually want it in the form y equals mx plus b, okay? Because this is our slope, and this is our y-intercept. Okay, that is the most useful way to write a linear equation. Okay, so if we have the slope, and we know the y-intercept, we can just plug it in to get the slope-intercept form. Okay, now, if we don't have the y-intercept, but we have the slope and we have the point, we could use point-slope form, which is this. And guys, you did this in Algebra 1, but you also did it in, you also did this last year in Honors Geometry as well. Okay, now say we don't have the slope, but we have 2 points. Okay, first we would find the slope. Now when I say find the slope, remember the slope formula is y2 minus y1 over x2 minus x1. Okay, so that's how you'd find the slope given these 2 points. So you have enough information, these 2 points to find the slope. And then we'd go back up to here and use point slope form. Okay, so those are the few different options we have to write an equation. All right, so let's look at example 1 now. Okay, it says the graph shows the distance of an asteroid 2012 DA14 travels in x seconds. Okay, so notice across our x-axis is seconds and across our y-axis is time. All right, so if I look here, I have a point and another point on the line. Okay, so one of my points is 524, and the other one is the origin, so 0, 0. All right, so notice up here, when we just have 2 points, the first thing we want to do is we want to find our slope. Okay, so our slope is, I'll write this out all for you, y2 minus y1 over x2 minus x1. And remember, this is the x-coordinate of point 1, the y-coordinate of point 1, x-coordinate of point 2, the y-coordinate of point 2. So if I plug this in, I get 0 minus 24 over 0 minus 5, which is just negative 24 over negative 5, which is positive 24/5. Okay, so this is my slope. Okay, now notice our y-intercept is 0, okay, because it crosses y at 0. So our slope would just be f of x equals 24 over 5x plus 0, or probably better written as just 24 over 5x. Okay, so that would be our equation. If we look at B, it said the asteroid came within 17,200 miles of Earth. Okay, that would be the distance from Earth, which is right here. So that would be my y. Okay, so I'm going to plug this in for y. Remember, y and f of x are the same thing. So 17,200. We want to know about how long does it take the asteroid to travel that distance. So 17,200 equals 24 over 5x. Okay, now to get rid of this fraction, let's multiply by 5 on both sides. Those go away. So we would get, this is 86,000 equals 24x. Divide by 24. I get x equals 3583.33, and that is seconds. Okay, well, that means nothing. I have no idea how much that is. So let's divide it by 60 to get minutes, to convert it to minutes. And when I do that, I get roughly 59.7 minutes. So I'm just going to say, well, that's pretty close to about 1 hour. Okay, so I'm going to say roughly 1 hour. All right, so let's look at example 2. It says the prom venues charge a rental fee plus a fee per student. The table shows the cost for different numbers of students, and this is for Lakeside Inn. Okay, the total cost Y in dollars for students at Sunview Resort, so this is for Sunview Resort, is represented by this equation. Which venue charges less per student? All right, well, the first thing we want to do is we want to find the equation for Lakeside Inn. Okay, so I want to get the slope first. Okay, so notice this is an additional 300. This here is an additional 300. This here is an additional 300, and this here is an additional 300. Okay, so for every 25 students, right? For every 25 students, we're basically adding $300. All right, so that means my slope is my change in y. I know my change in y is 300. Over my change in x, which is 25, which is just 12. Okay, and here I don't know my y-intercept, so this is where I'm going to do point slope formula. So I'm just going to pick, any point that I want, and I'm just going to pick this point here because it's on top. No rhyme or reason, just because it's right there. So I'm going to use the equation y minus y1 equals m parentheses x minus x1. Okay, so y minus, here's my y1, 1500, equals my m, which is 12, parentheses, x minus my x1 is 100. Okay, so if I clean this up, I have y minus 1500 equals 12x minus 1200. Add 1500 to both sides. So I get y equals 12x plus 300. Okay, this is the equation for Lakeside Inn. Okay, so for Sunview Resort, I add $10 per student plus a cover charge of $600. Over here in Lakeside Inn, I add $12 per student plus $300 for the whole thing. Okay, so which venue charges less per student? Well, guys, here's 10, here's 12. That would mean Sunview, ooh, can't spell, Sunview charges less per student. They charge 10 as opposed to Lakeside's 12. All right, so on part B, it says how many students must attend for the total cost to be the same. Okay, so basically it's saying, when is this equation the same as this equation? Okay, well guys, we can just simply plug that in. So when is 10x plus 600, when is that equal to 12x plus 300? Okay, so minus 10x minus 10x, I get 600 equals 2x plus 300 minus 300 minus 300. So I'm going to continue on over here. 300 equals 2x, divide both sides by 2, I get 150 equals x. Okay, remember x is the number of students, so they will be the same cost when there is 150 students.